So FreeForm Technologies, we offer a service called metal binder jet additive manufacturing. And this technology, we take a 3D model and then we build it up layer by layer in order to manufacture the part. This technology really works no differently than the printer in the office works, except for our paper is metal powder and our ink is binder that's holding the part together. So we spread powder across the build platform. We deposit ink on that powder to bond each particle together. And we do that layer by layer by layer to manufacture the part. After we go through that step, we go through a curing cycle, which hardens the binder, and then a high temperature sintering operation, which actually consolidates those metal powders to make a wrought-like metal part. When people talk about metal binder jet additive manufacturing, they most commonly compare it to metal injection molding. So I put together a little chart here to kind of show the differences and the benefits of both. Metal injection molding is also a service that FreeForm offers. When it comes to binder jet, the volumes are on the lower side. I put in here 100 to 25,000 parts annually. A lot of times that's dependent on the customer. If the customer doesn't want to capitalize tooling or amortize tooling, they can go higher. We have some parts that are higher in volume than that. And then metal injection molding is, 25,000 or 50,000 parts a month sometimes. You get into some really high volume, automotive applications for that type of technology. One of the major benefits of metal binder jet is tool costs. Sometimes it can be zero. You can just buy parts from the technology. There's no upfront cost. There's no upfront waiting time. We can manufacture parts right away. Sometimes there's tolerances that we can't hit, so we'll add a CNC operation or some other secondary operation, and there may be fixture costs involved with that. A metal injection molding tool can be $30,000 or more. That technology is using standard plastic injection mold tooling. So if people are familiar with that technology, our tooling for MIM works the same way as plastic injection molding tooling. Lead time is the other major benefit of additive manufacturing. You can get parts in days instead of waiting weeks for tools to be done or months before you see the first part. This is a big benefit because it also gives you the ability to iterate process or iterate design before you lock in and build a hard tool. So if you're on the fence or you don't know form, fit, or function, you're able to buy parts or several different iterations of a part and make sure it fits into the assembly or to the end use before hard tooling a product that you're going to spend $50,000 on. That can be a big benefit.
So Chris, just interrupting right there, if we've got customers on the line or maybe salespeople on the line who are talking to customers, and this topic is going to be fairly new for many of them, perhaps they've never even spent the time to research or discover if any of their parts might fit something like this. What are some of the things that they could look for to even determine whether or not they should inquire with a FreeForm or somebody like yourselves?
Yeah, certainly. I think the biggest or the most easy thing to identify is complexity. If you have a part that you can look at a drawing and you only need two-dimensional views to manufacture that part, there's probably a better technology to make the part. Which when you get into a product that has an isometric view, or you have holes at angles, or you have interconnected internal plumbing or geometries, that's when you start to get into ideally an additive part. Another good thing is if you have multiple setups in CNC, or you have 4 or more axes CNC machining. Things that are just XYZ, there's probably an easier, cheaper way to manufacture it. And we're never going to beat the cost of something that simple with our process.
Hey, follow-up question for you. Oh, go ahead, Mike.
A follow-up to that, can you combine traditional manufactured parts with additive manufactured parts, right? So that are they complementary or is it kind of one or the other?
No, we have parts today that we print a part and then our customer welds them to another part or assembles them with a traditional fastener, things like that. And honestly, a lot of times those are good wins for us, because if I know that up front, I can go to the customer and say, well, why don't we just combine them in printing, and you can remove that assembly operation from your step, and now we can kind of reduce your bill of materials. That becomes kind of a cost savings for people as well.
Okay. Question on mine. So in terms of this machine, that it's the metal binder jet machine, does one size fits all with regards to these machines? Once you get one in, they can do everything, or does it depend on the project, the type of machine you're ultimately using? I don't know the scope of how differentiated these machines can be.
Yeah, certainly. So we have 5 different machines. We have 5 machines. 3 of them are identical to each other, and then 2 are different. We have 3 that are more production machines. They have bigger build boxes, so we can fit more parts inside the envelope. But they are limited in materials that they can produce because of the types of powders that they use. And then we have some smaller machines that are more lab or development type machines, and we're using those to develop process and develop materials so we can get into different materials long term for our customers. So the production machines we have today, you'll see down below there that we're limited to 17.4, 316, cobalt, chrome, and Inconel for some of our higher end materials from a production standpoint. But material development, we've done S7, we've done 4130, 4140, 8620, nickel free stainless, 15. I could go on. We've done a lot of material development for both ourselves, for the powder companies, and for end users that want to develop technology for their products.
Excellent.
And Chris, I feel like we're attacking you on the slide, so I apologize. But just to
love
clarify, there's 2, if I'm hearing right, there's 2 methods to go about additive manufacturing. It's either metal binder jet or metal injection molding. You can either do that in-house or you can work with someone like yourself. Is that correct? And you use metal binder jet.
Yeah, so metal injection molding is not an additive technology. It's more of a traditional injection molding technology. It's just another technology that we offer here at FreeForm. And if you're using MIM components today, metal injection molded components today, they might be a fit for metal binder jet if volumes are lower or you want to add complexity or things like that. So I kind of talk about these in tandem because they complement each other very well. And we offer both of them, and they need some of the downstream processes like sintering, which is a big investment. So it's a good complement to offer both.
Great.
Yeah, and I think that's a great point, because it could be, you don't just dive straight into metal binder jet or additive manufacturing. Maybe it's a segue of picking out certain parts within metal injection molding that you say are more applicable or better fits for
Yeah, I'll tell a quick story. You know, when we first got started, we had a customer come to us and they wanted 5 parts. And so we printed them 5 parts, they got them in their hands, and they said, you know, yeah, these are good, but we want to change a few things. So we made a few changes. They wanted to print 50 pieces. Okay, printed 50. They're like, this is great. Let's market test this. Let's buy 500 and we'll put them in the hands of our users. They got those 500 and they were like, okay, we want 50,000 of these a month.
Oh, wow.
And I was like, well, I can't print. I mean, there's just not a technology today to print 50,000 pieces a month. So it's not a thing. So we had to at that time to build a metal injection molding tool and launch a MIM process for that customer. But it's the perfect segue, and Mike will show it at the end there with that bell curve. It's like now we can, with additive, we can serve your first idea of a part, and then at the top of your ramp peak decline, you know, your peak volumes, we can offer MIM. And then when we get to the backside of obsolescence, now we have a validated additive process. We can go back to that without increasing costs or setup times, things like that.
Great.
From a commodities perspective, our main commodity is metal powder. We buy a special cut of metal powder that is produced by a process called atomizing, which they take molten metal and they use gas or water to make it into metal particles. We use, if you do research, you'll see about like conventional powder metal that's more popcorn shaped. We use spherical, almost perfectly spherical powder. So it's pretty expensive powder, and it's made with a special process. And pre-COVID to today, we have seen some pretty dramatic price increases on our raw material, 36% on the 17.4 and 28% on the 316. We've been fortunate from a FreeForm perspective because we do buy pretty significant quantities. So we have not seen that type of increase from our vendor, but that's what they're seeing. We're able to put in blanket orders and kind of lock in pricing for a long time.
So Chris, just kind of taking a full circle, is it possible that the circle of life could be, you know, either Ryerson or one of our customers, if they cut off a small piece of 316 stainless, somebody eventually buys that in the scrapyard or at one of these powder manufacturers, they melt it down, molten 316, blow some argon gas or some sort of gas into it, and then that becomes your raw material?
That's exactly what happens. I mean, metal is the most recyclable material that we have in the universe. And that's exactly what's happening. So, you know, we're not buying, you know, old refrigerators or things like that, but, you know, pure scrap that's coming from a bit like a service provider, machine shop, you know, distributor like you guys. That's exactly where it's going. It's going back to the mill and it's getting atomized into powders.
It's a beautiful thing.
So these are some products today manufactured by FreeForm in our three main industries. We work outside these industries, but I think that these are the most have the most product examples: medical, defense, and industrial applications. We're seeing a dramatic increase in industrial applications, mostly what I would describe as valves and controls. Anything that's moving a media, whether that media is water or gas, and you want to put it in a specific direction. Additive manufacturing is a good way to do that because you can now manufacture internal plumbing and geometries that you can't traditionally machine with another technology. So we're seeing that grow pretty fast, and we're able to, our technology is growing. We're going to make larger parts, which is good for that as well. Medical is great because these products would usually go to MIM or investment casting. But the medical life cycle is really long. It can be years from the time you make the first part till your time you're actually at production. So having medical customers not locked into hard tool costs allows them to develop product faster and more cost effective and get it to market quicker. And then defense that's a pretty traditional investment casting and MIM rich industry. So there's a lot of product development prototyping that goes on in that market. So we're able to do that quickly for them and then ramp up into production fairly quickly.
Chris, I like the slide because what you've always long characterized. If I look at these things, I can pick up any of these things and fit them in the palm of my hand, and that's kind of the adage, right? Is like if it's a fit for additive, it's what, the size of a softball, you say?
Yeah, I think I just had this conversation the other day. If you would have asked me 2 years ago, I would have said a golf ball, and then last year I would have said a baseball, and then today I'm very comfortable telling you a softball. With the
12 inch or 16 inch.
What's that?
12 inch or 16 inch.
Yeah. Yeah. With the tools that we have today, both quality tools and scanning tools and simulation software, the technology is advancing day over day. It's not stagnant by any stretch of the imagination. I don't know how much larger we can go because the material gets expensive. It's that's more for the customer to decide than me. But we are getting more and more, we are more and more successful every day with larger parts. Yeah, this is that curve I was talking about between our two processes of additive and metal binder or metal injection molding. We can now support the first idea you have for a product, the first form, fit, and function. We can service your millions of parts annually. And then when you get out of that phase out and obsolescence, now we have validated processes to serve, all stretches of volumes for your products.
Excellent. And maybe I'm putting Mike and Chris on the spot here with this question, but if we do have customers, we have salespeople who have an inquiry and they want to access FreeForm Technologies. Like I said, they're not a company of Ryerson. How would we recommend that route go? What's that ideal path for how a customer might want to approach?
It's a good question. We have an email address set up, additive@ryerson.com, if you want to send your inquiries, and we'll make sure we get it filtered to Chris. That's additive, ADDITIVE @ryerson.com.
Thanks for that spelling, Mike.
It was tricky too. We got a few questions rolling in. I figured it'd be a good time to tackle some of those. Chris, do you think that additive is a good replacement for castings or forgings?
Replacements, that's a hard question to answer, because if we're looking at from just a traditional dollar for dollar standpoint, it's not always going to be better. Actually, I would say most times it's not going to be better dollar for dollar. We have to solve a problem, whether that's a supply chain problem or a bill of materials problem, or reducing a machining step. We need to be able to look at the total cost of ownership of that part, not just, it's not really apples to apples all the time, but those are two technologies where we see our material properties are a fit for replacement.
Yeah. And then you had mentioned material earlier on, like 316, 17.4. How about a carbon steel equivalent, like A36?
I have to look at the chemical composition of the materials we have done, but carbon steels that we have done today would be 4140, 4130, and 8620. So I would think that between those three, there's got to be a correlation for what that customer is looking for, or that person's looking for.
Cost effectiveness. How cost effective is metal binder jet / MIM versus traditional milling machine work? Are these metal powders as available as traditional raw material?
Our raw material availability is good. We have not had any issues getting raw material. We issue blanket orders to our vendors regularly, so we have enough in the pipeline to get cost effective process for process. If it's traditional like 3-axis milling, that's probably still going to be cheaper. But if you have 4-axis or 5-axis machining, that's where we start to add some bang for the buck.
Gotcha. You might have mentioned this. Can aluminum parts be made in this way?
Not yet. There's a lot of development. I shouldn't say not yet. It is possible, but not commercially possible. There's a lot of development happening in that space. If you do some research on Desktop Metal or X1, they have some excellent materials out there about where they're at with the development. Those are the makers of the equipment. They make the printing equipment. And there's a lot of interest in automotive and other industries about that material. It's just, there's a very narrow window of sintering temperature for aluminum. So there's an art to that process as much as there is an engineering aspect to it as well. So that is coming, but no, I could not make aluminum parts today.
And Chris, you're getting a flood of questions here. I'm going to give you one more before we move on to Nick, and we'll make sure we filter the rest of these. So, I mean, we obviously a lot of interest in this, but this is a QA one. Are you able to provide a certificate of analysis after material is molded or formed?
Yes. Yeah. So we get a cert from our vendor when we buy materials, and then we can also do chemical composition prior to shipment if that's desired for the customer. We have access to a lab here locally that we do that through as requested, so that's not a problem.
Great. All right, we'll hold the rest.
Yeah, I know we ran probably a little longer with our special guest this week than maybe we normally do, but I think it's worthwhile and it's important to do so because this is a topic that's so different and so tangential within the manufacturing space than what we normally talk about. So we appreciate Chris's time for joining us on this, and he's going to stick around till the end to take additional questions to the extent there are.